quickly. Now, contrast that with another product of Canada, which is the Tilley hat. And these Tilley hats are indestructible. If Tilley stopped making their hats today, there would be Tilley hats on hikes all through North America and Europe for coming generations, because they are made to last for a long time. Now, with the NPC protein, if we block production of that protein, we didn't really know in the liver itself how long it would be before the NPC protein would disappear and disease would begin. As it turned out, the NPC protein disappeared pretty quickly. And so by 2 weeks, all of the NPC1 protein was gone from this treated liver. And now we could follow disease progression throughout the mouse's lifespan. What we did was to harvest blood and tissue samples from these mice after 2 weeks, 4 weeks, 6 weeks, and 9 weeks of treatment. Now, here what I have is a liver from a control mouse. So this is a normal-looking liver, and it's been sliced very thin, and it has been stained with dyes that are just meant to show the normal characteristics of the liver. And it's a little dark here. There are a couple of very obvious landmarks in the liver. There's an artery that is bringing oxygen-rich blood into the liver. There's a vein that's bringing nutrient-rich blood from the intestine into the liver. And this blood cycles past all of the cells of the liver through these little channels called sinusoids until it gets to another vein where the blood then leaves. And there are little cubey cells throughout the liver here called hepatocytes. And they have sort of a reddish cytoplasm and a dark blue nucleus. There are lots of other little cells lining the sinusoid, but in a normal, healthy liver, we don't really see very much of those. Now, in a liver that has had NPC knocked down, there are some changes in the liver. First of all, the liver gets much larger than normal, so there's a hepatomegaly. We very quickly see liver enzymes in the blood of the mouse, and that's a sign of liver injury when enzymes are being released into the blood. When we take a bit of liver and we look for the storage of cholesterol, we find that indeed these cells, this organ is showing the cholesterol storage very quickly. You also hopefully can see these clusters of sort of clear-looking areas and a very dark dot there, and that's the nucleus. These are big lipid-filled macrophages that are infiltrated in and are sort of part of the immune system, and they are rapidly engulfing injured cells. They're engulfing lipoproteins, and so these are cells that are very characteristic of a liver that is storing a lot of fat. So there are many more macrophages, and there are many fewer hepatocytes. And what you can't quite appreciate from this slide, I know, is that the hepatocytes look a little lighter in color. And I think that's because they're storing so much lipid within them. There are also many more inflammatory cells. There are these dark dots here that are blood-borne inflammatory cells that have infiltrated into the liver. And these are cells that can detect damage within the liver, and they come in and they're trying to repair that damage. And very often, these cells will sometimes do more damage than they repair. They will be secreting various factors that are recruiting more inflammatory cells, recruiting other cells to come in and try and repair damage. They will also activate some of the silent cells. I mentioned that there were some cells that were throughout the sinusoid that are there sort of silently. We hardly notice them normally. They're called stellate cells. And in this injured liver, those stellate cells become really activated. start to lay down extracellular matrix and lead to a condition called fibrosis. Here, which again I know is quite dark, we have stained the fibrotic material with a blue dye, and so you can sort of see there's perhaps a blue ring around these vessels and blue material that's surrounding all of the macrophages. And that's the fibrosis that is beginning to infiltrate throughout the liver. So when we carry out this knockdown of NPC1 in the liver, we find that the liver becomes enlarged, enzymes appear in the blood, there's cholesterol storage, more macrophages and fewer hepatocytes, lots of signs of inflammation. There's a spread of the stellate cells and fibrosis. Now, none of this were really novel findings. They were very reassuring to us because what they did was really recapitulate the liver disease that is seen in the typical golden standard NPC mouse, which is called the NPC-NIH mouse. Liver disease has been characterized in that mouse, and what we see here in our mouse looks very similar. What that allows us to do, though, I'm going to show you some new things that we can do with our mouse that are more difficult to do with the NIH mouse. Now, for one thing, other than this liver disease, our mice are really quite healthy. These oligonucleotides do not circulate from the blood up into the brain. They're taken up by the liver so quickly they don't get really around to the rest of the body. The mice are otherwise completely healthy. There's no weight loss in these mice, which I mentioned because that was a feature that Dan was surprised at, because a lot of our nutrient uptake and control of feeding does center on the liver, and so you might imagine that